Hello, good day. My name is JUDE IBIAM. I'll be taking you part 221 Statistics for Public Administration 2. It is a 2 credit unit, as you know. So, at the end of this study session, you are expected to know how to define a variable, how to list and explain the types and classes of variables, and also to discuss the different ways of measurement. So let's go straight to the business of the day. A variable is any characteristic of an object or concept that is capable of having different values or falling into more than one distinct category. For instance, a bool object for the characteristics of a building such as size, type, cost, and ages are variables. These varying attributes is what is known as a variable. Variable, therefore, are properties or characteristics of some events, objects, or persons that can take a different value or amount as opposed to constants. Variable can take numbers or labels. A variable could come in different forms. They could come in categories or numerical forms. That is why they are further classified into quantitative and qualitative variables. They are characteristics that can be counted or measured. And a collection of variables gives us what we call a data. For example, when we have a column of height, a column of weight, and a column of maybe length, and we have numbers under each column, these are variables, but when you look at them collectively, that's what is called a data, and we can use it for statistical analysis. So moving forward, classification of variables. Variables are grouped into several categories, and they include the qualitative and quantitative variables, as I mentioned earlier. They could also be independent and dependent variables. They could be exogenous or endogenous variables. So we'll take them one after the other. For the quantitative variables, these are variables which take on values that vary in terms of magnitude. Their values result from counting or measuring. That's what should first come to mind when quantitative variables are mentioned. Numerical values, counting. Alright? Quantitative variables are measured and expressed numerically. Examples of quantitative variables include height, weight, distance, age, annual income, amount of rainfall, scores in a test, interest rate, etc. Quantitative variables are further classified into two types. That's the discrete and the continuous variables. In quantitative variables, they always take whole numbers or integers. They don't come in form of fractions or decimals. For example, if we want to count the number of cats, we could say there are 8 cats, but it's not possible to say there are 8.5 cats. Neither is it possible to say there are 8.5 cats. So it always takes a whole number. That's for the quantitative variable, the discrete quantitative variable. The quantitative variable, as I said, is divided into the discrete and continuous variable. So the discrete variables now, they are quantitative variables whose values are expressed in whole numbers or rounded numbers. They can only take a finite number of values. This means that numbers consist only of integers and not fractions. On the other hand, continuous variables, which are also the other type of quantitative variable, can be anything that can be measured, likes of distance, speed, weight, and so on. So continuous variables are numerical variables whose values assume theoretically an infinite amount of gradation between any two values. Continuous variables thus take on infinitely uncountable values. Example of continuous variable. More examples on that. We have age in forms of 2 years. We could say 10 months. We could say 5 hours. We could say 4 seconds. We could say 4 milliseconds, 8 nanoseconds, and 99 picoseconds. These are examples of continuous variables under quantitative variables. Moving forward, going to the other classification of variables, that's the qualitative variable. Qualitative variables are variables that take on values that vary in kind rather than in magnitude. They are characteristics that can only be expressed in words. They are descriptive variables based on observations. Qualitative variables are not measurement variables, thus their values do not result from measuring or counting. In other words, they differ in types or attributes rather than in quantity. They could be things that could be related to observations, like let's say the 5 senses, things you could see, hear, taste, or smell. For things you could see, it could be colors, different type of colors. For things you could feel, it could be hot or cold in the degree it is. For things you could taste, it could be delicious or not. For things you could hear, it could be loud or silent, and things like that. In other words, they differ in types and attributes rather than in quantity. Qualitative variables include all observable qualities or characteristics of a group or population. More on the examples, they include hair color, eye color, skin color, religion, political party, profession, and so on. Qualitative variables are grouped into two: the nominal variables and the ordinal. The nominal lack order of criterion of order, while the ordinal maintain a specific order. So another classification of variables are independent and dependent variables. An independent variable is a variable that influences the behavior of another variable. It is used to predict the value of another variable. The dependent variable is sometimes called the outcome variable, and it is the variable being predicted or measured in a research. In the case of independent and dependent variables, the functional relationships the functional relationship is stated as thus: y is equal to f of x, which means y depends on x. Any value x takes affects the value of y, with x being the independent variable, while y is the dependent variable. Other classification of a variable are endogenous variables and exogenous variables. Endogenous variables. A variable is said to be endogenous within the causal model if its value is determined or influenced by one or more of the independent variables, excluding itself. While on the other hand, an exogenous variable is a variable that is not affected by other variables in the system. It is a variable that is not influenced by any other variable in the model of interest. The value of an exogenous variable is fixed in model, that is, it is not determined within the model. So we move on to measurements of variables. Under measurement of variables, we have the nominal scale, the ordinal scale, the ratio, and the interval scale. So for the nominal scale, this is the lowest and the simplest scale of measurement. It simply sorts out objects into categories and assign numbers as labels to identify objects or classes of objects. The assigned numbers have no meaning except as identifiers. The nominal scale is a qualitative form of measurement. That means it is categorical. For example, we could have three colors, let's say green, red, and blue. And then let's say we assign arbitrary numbers to them. Let's say the green is 1, the blue is 2, and the red is 3. In this case, there is no specific order. We could still bring the red to 1 and take the green to 3. It will not change the variables in any way. The order in which they appear does not matter in a nominal scale of measurement. So it means either of the colors could take either of the arbitrary numbers, and those numbers cannot be used for statistical analysis because they are just serving as labels, not as values. The only way we will be able to use such a data for analysis might be when we kind of involve the responses of people, like to say to show how many people prefer red color, how many people prefer green color, how many people prefer blue color out of 10. If we have 5 people preferring red, blue people preferring blue, 3 people preferring blue, and 2 preferring green, we could say 50% prefer red, 30% prefer blue, and 20% prefer green. That way, having these percentages, we are able to use the numbers for statistical analysis. But in the initial form of red, green, and blue, we cannot use such variables for calculations. Going forward to the ordinal scale, ordinal scales, like the nominal scale, they sort variables into mutually exclusive categories, assigning numbers to objects. In addition, they rank them. So it means in this kind of measurement, the order of arrangement is paramount. It's important. For example, when in a race you have someone who comes first, second, and third, there has to be an order: first, second, third. You cannot arrange them by bringing second before third, then first. It has to be either in ascending or descending order. That's the way it goes. Or if you are kind of wanting to assess a particular product in the market or a student's performance in a test, you could categorize it as excellent, good, satisfactory, or bad. That way you are able to give information about a person's performance. You could also assign arbitrary values to these characteristics, like the excellent could be 1, the good could be 2, satisfactory 3, and bad 4. You cannot bring in good as first, then excellent following good, and then bad before satisfactory. So in ordinal scale, the order and ranking is very important. Let's move on to the interval scale. The interval scale provides the information on how much a category is more or less than the other. In interval scale, the order also matters. I could give you examples of, let's say, temperature, the temperature of different states. Let's say we are considering 3 states and we have 30° for one state, 60° for Fahrenheit for another, and 90° Fahrenheit for another state. We could see that the order should go 30, 60, 90 showing it in ascending order. It's not possible to say it has a 0 starting point. The interval scale does not have a 0 starting point, because going by the example of temperatures, 0° does not necessarily mean the absence of heat. 0° does not necessarily mean the lowest temperature. Temperature goes beyond 0. There are temperatures of negative values. You could have -8°, -4°, and so on. So the interval scale does not start from 0. So when you say the interval scale has no absolute 0 point, that's what it means, that it cannot start from 0. So in summary, it provides information on how much a category is more than the other. Let's say if you subtract 60° Fahrenheit from 90° Fahrenheit, you could clearly see that 90° is 30° more than the state with the 60°. So the difference we are able to measure the difference. That's what the interval scale provides. As for the ratio, it has an absolute 0 point. For example, number of vehicles in a queue, height of a person, distance traveled, accident rate. The order of arrangement here matters. For example, I'll give you another example. The grades of a student in a typical statistics examination, let's say the scores are ranging from 30, 56, 70, 82, and 90. We're able to measure the difference between the score of one student from the other by simply subtracting the score of one student from the other to know by how much, by how many, or by how many marks a particular student scored more than the other. And the racial scale is said to have an absolute 0 point because it is possible for another student to score zero. It is possible to include zero to this list. That's to say the person was not able to write anything during the test, or the person attempted but didn't pass or score any score. So it's possible to get a zero in a test. So variables concerning ratio scale usually start from zero. You go start counting from zero, then one, two, or as the case may be. So that is it on ratio scale. Thank you very much. See you in the next class.